Question 3, proving by induction that 3 to the power of 2n minus 1 plus 1 is divisible by 4. First stage in a proof by induction is to consider n equals 1. And if we sub in 1, we get 3 to the 2 minus 1 plus 1, or 3 plus 1, which is 4. And that's divisible by 4, so it's true for n equals 1. The next stage in a divisibility proof by induction is to consider f of k plus 1 minus f of k. And that turns into 3 to the 2 k plus 1 minus 1 plus 1, take away 3 to the 2k minus 1 plus 1. The 1's cancel out, so it reduces to 3 to the 2k plus 1, take away 3 to the 2k minus 1. That in turn becomes 3 squared times 3 to the 2k minus 1, take away 3 to the 2k minus 1. And that in turn becomes 8 lots of 3 to the 2k minus 1. We then rearrange and say, in that case, f of k plus 1 is equal to 8 times 3 to the 2k minus 1 plus f of k. But proof by induction involves assuming the result is true for n equals k, which means f of k is divisible by 4 by the inductive hypothesis. But 8 times 3 to the 2k minus 1 is divisible by 4 by inspection. And put them together, that means f of k plus 1 is divisible by 4. So it's true for n equals k plus 1. And therefore it's true for all positive integers n by the principle of mathematical induction.